Okay, so pull the pen up here. Let's use red for this first part. If we're thinking of where we are decreasing, you have to give the domain where you are decreasing. And that is going to be the x values. I use Desmos graphs on a lot of these because they're the easiest. It's the easiest way for me to graph things. Desmos does not put arrows on the end of their graph, but if you see a line going all the way to the edge of the graph without a closed circle or an open circle or something like that, assume that you have arrows on the end of that graph. Same thing on the quiz tomorrow. If it goes all the way to the edge of the graph and it doesn't have a closed circle or open circle, assume that that keeps on going. If you are unsure if there should be an arrow, just raise your hand and ask me and I'll tell you if there should be an arrow there. But if it goes to the edge, you should have an arrow. So if I'm thinking about where this is decreasing, if I start on the left side, I decrease. I'm on my roller coaster going down until I get here, right? And then, I'm going to put an arrow on that end, and then I would switch right here to increasing, right here. So, my decreasing here, I've got to give the domain where this happens. So this is just like we were doing domain and range, right? So over here, this is sometimes confusing to kids. Am I decreasing like way over here? Right? If I'm going from left to right, am I decreasing way over here? I am, right? Like I would be way up here. I'd be going down until I got to 0, right? So you are decreasing on this entire domain. So you want to think about x values where you are decreasing. You're decreasing way over here at negative infinity. Okay? Students mess this up because they want to start from the middle of the graph and go up and say this is increasing all the time, right? Like both sides are going up. But we're thinking left to right. So over here on the left, you are going down until you get to the middle of that graph. You have to give the x values where this is happening. So for decreasing, it's going to be negative infinity to where do we stop decreasing at? 0. And we're looking at the 0 on the x-axis for this particular problem. It's also the 0 on the y-axis, but that's not always the case. We're looking at the x-axis for that. And we want to use a bracket for that. It seems a little odd to use a bracket there. It's actually a little debated, like this is a calculus topic that's a little bit debated, like some textbooks do it differently. When I was in calculus in high school, my teacher taught that like you should not include 0 because like it's decreasing and then it switches right here to increasing, so it's neither. But based on the definitions that most textbooks use, it's both, like it's decreasing, but it's also increasing there. Like it's a little weird, but honestly, I'm not going to give you one answer that's negative infinity to 0 with a bracket and one that's negative infinity to 0 with a parenthesis. So if you're just getting the numbers right, you're probably going to be okay. These are usually going to be multiple choice questions. So, we also need to know increasing. And increasing is going to happen right here. We're going to pick up increasing at 0. Seems a little odd to use a bracket there because it feels like we're, like you can't be increasing and decreasing at the same spot, but I'm not going to get into the definitions of increasing and decreasing technicalities. I doubt that will interest you. Just take my word for it on that one. And then this will go over all the way to infinity for that. The wrong answer I see for this the most is that for decreasing, students will say infinity to 0. Why do you think they do that? What? It's going up. Like that. But when you're thinking about this going up, you're thinking about its y value. So you got to think from the x-axis every time. And I also know this has to be wrong because positive infinity is bigger than 0, and we can't write interval notation that way. So watch out for that. You're always thinking about the x-axis on this. All right, so if we look at our next function, we're looking for increasing, decreasing, constant. So if I start over here on the left, I am going to be, there's an arrow right here, I'm going to be increasing. I'm going up till I get right here, and then I'm switching right here to decreasing till I get to this point, and then I'm increasing again. It may even be helpful for you to like think of drawing in sort of like a vertical line right there to section this off like that. Like that middle part right there is where I'm decreasing. Think about your x coordinates where that is happening. So over here on the left, my x coordinate for that would be right here at -4. And then my right coordinate would be right here at +2. Pretty much going to use brackets all the time for this unless you got an infinity or unless you see like an open circle. You can't have a bracket somewhere where there's an open circle on the graph. Since it's functions, they're usually not going to include that. Okay, questions on the decreasing part? For increasing, we're going to have two separate sections. So we got to list those separately. We'll use the union symbol for that. For this first section where we're decreasing, where do I start? So I'm thinking about, got to be thinking about x-axis. So where do I start over? Am I decreasing over here? I am. And not because this is going down. I'm sorry, I'm saying decreasing. I'm increasing over here. This is going down, but am I starting from up here? I'm not. I'm going left to right. So left to right, if I'm way down here, I'm still going up, right? So you're increasing at -infinity all the way up until you get to -4. So your increasing section will be -infinity to -4, and then we'll use a union symbol, and then from 2 to +infinity. Okay, questions? All right, let's look at using Desmos for this. So if you got your computer up there and want to graph it on your own, that'd be lovely. I still have a Desmos pulled up. I don't think I do. I want that. This. I want to make both of these bigger. Really like this will be okay. Desmos. All right, so if I graph this first one, it's just a line. Is that increasing, decreasing, or constant? Okay, it feels like it should be constant. There is a constant rate of change. So in some ways, constant feels right. It has a constant rate of change, but we're not talking about if it has a constant rate of change. We're talking about if this is a roller coaster and we go from left to right, are we going up or are we going down? Or are we going on a straight line? All right, we're going up in this case. So this one's going to be increasing. Does it ever change from increasing and decreasing? All right, does it ever stop? right? This would not be a good roller coaster to be on. You're just like headed out into outer space forever in one direction, I guess. Like, so it's not gonna be a great ride for you. But this one we would say is increasing from negative infinity to positive infinity. A constant, and I think, if I'm remembering correctly from last year, I think I forgot to put a constant in the notes. A constant has to be a horizontal line. So you don't see it in a lot of like functions naturally unless you're just looking at a horizontal line. Most functions don't have a section that's horizontal. The only time you really see it is if it's like graphs that we were looking at where somebody's created it and put like a piecewise function where you got this piece of horizontal and then a slanted graph. So we would be increasing here, and you are not decreasing at all. No decreasing at all on that. Okay, questions on that one? All right, if we graph our next one, we got y equals x squared. Okay, this is just a parabola, right? Pretty basic graph here. I mostly want you here to look at how Desmos can help you check your work really easily for this if you're given the equation. So we need decreasing and increasing. We got both of those going on here. If I start on the left, I always have to start on the left. Am I increasing or decreasing at first? I'm decreasing, right? And I stop decreasing at 0. So I'm going to stop decreasing at 0. Where does this section start at? It's basically the left side of the graph, right? Where does it start over here? It is not positive infinity. But I'm so glad you said that, Heston, because it's what people do wrong most of the time. It seems crazy that I'm telling you that's not positive infinity, right? Because it's clearly going up. But when you think about up or down, you're thinking about range, right? Up or down is your range. So what we're doing here is like we are thinking about what the x values are there. So like when this keeps on going right here, we're not thinking about what the y value is. So like if you look at the numbers, you know, like here's 12, 13, 14, 15, 16 when you look at y values. We're thinking about what the x values are doing. Our x values, like here's -2, -3, -4. If we could keep on going past that, what are our x values doing? They're decreasing, right? That's negative infinity for that. So you got to think about the x-axis right here. So over here, your x values are negative infinity, not the y-axis. And that is very confusing because on that graph you see it going up and you want to put positive infinity. And then it stops decreasing at 0 and you're going to use a bracket with that one. Now, here's where it might be a good idea for us to think about inequality notation a little bit because I'm pretty sure, let me make sure this is the truth. I don't think you can put it, oh, you can. If I type the word infinity in, yeah. You cannot do interval notation in Desmos, but you can do inequality notation. It'll sort of highlight the graph for you. So if I've got from negative infinity to 0, like on the number line, you got negative infinity over here, you got 0 right here, and we're talking about everything here below, right? So that would be like x and 0. Would I use a less than or equal to or a greater than or equal to for that? So if I've got all the numbers from negative infinity to 0, those numbers less than 0 or greater than 0? They're less than, right, because they're negative. So less than or equal to. And then if you type that in, you can make sure that it highlights the part of the graph you were actually talking about, right? So that, yes, that's the side that we meant to say is decreasing for that. You won't see the answer choice positive infinity to 0. You won't see it. Because can I ever have an answer that's positive infinity to 0? I cannot, because the bigger number always has to be on the right. So the good news is like that misunderstanding is not going to be an answer choice, at least not on my quizzes. I can't promise what they will do on the EOC, but I don't think they usually do it. So you'll at least have to stop and think, wait, something's not right there if you get that as an answer. And then so if we're thinking about increasing is easier because increasing is the other side of this. It's 0 to positive infinity. And it's easier because even if you're thinking of it wrong, you're still going to get it right on this because the side does go up, but that's not what you're thinking about. You're thinking about what your x coordinates are doing. And like here, my x coordinate is 0. And then, if I follow it up, there's 1, 2, 3, 4. I'm thinking about what the x coordinates are doing for that. Whenever I give because you're given the domain for that. And if you wanted to write that in inequality notation, that's all the numbers greater than or equal to 0. And you can see if we do that, x is greater than or equal to 0. It's going to highlight the other half of the graph in purple. So you can kind of check to see if that's what you're looking for. Okay, questions there? All right, let's keep moving. Got more to do. Okay, this one is a little bit of a trick question. I mostly am putting this one here to prove a point. If I look at this table right here, it's asking where the function is increasing, decreasing, or increasing, decreasing. It doesn't ask for constant here, but it could have. So I know from like -1 to -2 what's happening there. Am I increasing or decreasing when I go from here to here? That's decreasing. All right, from -2 to 3, or -3, that's decreasing, right? How about from -3 to +2? That's increasing. Let me switch colors there. All right. That's increasing. How about from 2 to 6? Also increasing, right? Now, if I wanted to give a answer for this, I could say it is maybe decreasing. I would give the x coordinates for this, right? 0, so I'm using the x coordinates. 0, 2, 2. All right, I'm pulling the x coordinates from here. And then if I'm talking about increasing, I could say that it's maybe increasing from, use your x coordinates, not your y coordinates. So 2 to 4. This table supports that that might be what's happening there. But why am I saying maybe? Why am I not saying, yeah, this is it for sure? Tables only give you selected values, right? I don't know anything about this function. It could be just a list of points. Like there might not be anything in between there. Do I know what happens at 0.5? Does it tell me what happens at 0.5? I do not know. It might be. It kind of looks like it should be like -1.5 or something like that, right? But could it be 8? There's nothing telling us that it's not, right? It could be this crazy graph that just like goes all over the place, right? So make yourself a note right here. You can not make definite conclusions from a table. All right, meaning that you can't know for sure. So if the question is worded something like, this table supports that the function is increasing, maybe you could have that. But tables we can't know for sure because we don't know what's happening in between these numbers, right? So there might be numbers left out that we don't know about. So that's mostly just there to let you know that that's the case. Now, let's talk about positive and negative, because positive and negative sound a whole lot like increasing and decreasing, and students get them mixed up a lot. Okay? A function is positive when its y value is positive. Oh, gosh. Let me erase that. Let me erase all that. I haven't written anything here. All right. When its y value is positive. And a function is negative when its y value is negative. So it's those y values that we care about. The way that looks on a graph, a function is positive when it lies above the x-axis. And that function is negative when it's below the x-axis. Okay, just to like sort of prove what we're talking about, think about graphing a few points. Like this coordinate right, this point right here is the point -6, 4. It has a positive y coordinate. It is above the x-axis, right? This point right here is the point 4, 2. Positive x coordinate, positive y coordinate above the x-axis. Something like this, 0, 6. Positive y coordinate above the x-axis. But if I pick, I should have used red for that. That's usually what's used for negative. But if I pick numbers down here, like this point right here is -4, -2, below the x-axis. Y coordinate is negative. Right here, this is 0, -5. This point over here is 8, -2. So it's the y coordinate that matters, and that either puts it above or below the x-axis. So when we're asking for positive and negative, it's a different question than increasing and decreasing for that. Questions there? All right. So for this, this is starting to ask us for everything. How many more? We got one more after this. I don't know if that's okay. Yeah. So this one's going to ask us for everything. So if I'm looking at 6, I want domain, range, increasing, decreasing, or constant. Although I did fail to put a constant example on here, so I apologize for that. And then positive or negative. Okay, so we got to do this like a piece at a time. So for number 6, for our domain, we got closed circles on the end. So this stops. There's no arrows on the end here. And on the left, the furthest I go right here is -5. On the right, the furthest I go is +5. It's connected all in between. So that's my domain. For my range, I'm thinking lowest to highest. This is the range is the only time you think about y values. Okay, so this lowest y value, what is it right here? So like this is my lowest point. What's the y coordinate there? What do you think, Caleb? It's 0. Okay, and then I think of my highest coordinate. What is the y coordinate of my highest point? It's 10. All right, so range only time you think about y coordinates. Every other time you're looking at the x coordinates, right? So domain and range are given. This function is not too bad for increasing, decreasing, and constant, because if I'm going from left to right, this function only does one thing. Is it increasing, decreasing, or constant? It is increasing, right? So this one's increasing the whole time, which means your increasing is going to be the same as your whole domain. The whole function is increasing. It increases here from x value is -5 right here, and it increases all the way over here to this point. X coordinate is +5 for that. There is no decreasing, so it would be none. There's no constant. Okay. All right. And then positive or negative. So that's the one we haven't looked at yet. Positive is above the x-axis. Negative is below the x-axis. Is this graph ever below the x-axis here? It is not. Now, this one is just a teensy bit different. It is definitely positive all here, right? We're above the x-axis. Am I above the x-axis right here at this point? Not above the x-axis. What am I? On the x-axis. Is your value positive there? Is it negative? It's not negative either. It's neither one, because 0 doesn't have a sign, right? So whenever they ask positive or negative, you're most of the time going to use parentheses for that like point that's on the x-axis. Again, I'm probably not going to try to trip you up too much on that. But like, we're not going to include that point at -5 because we're not positive or negative there. So we would be positive from, oh, look at me. Ignore that. Parentheses, -5, up to, we can use a bracket for the +5 because we're definitely above the x-axis here. So we're going to include that. Is it ever negative here? Is it ever below the x-axis? It is not. Okay, so these are the like key things that we'll be looking at. For 7, we have got, it didn't copy great. I would like to see a dot right there showing us that it stopped, but it doesn't have an arrow. If it's on the quiz, I'll make sure there's a dot there. So for this, we need to think about domain. What is our point that is furthest to the left here? What's our x-coordinate furthest to the left? So Carson, what would we use for our first number for our domain here? What? I think that's 5. But for domain, is that the number we want to look at? For domain, we got to be looking at not the y-axis, but the x-axis. What's your x-coordinate at that point? Is 0. So it's really easy to get that mixed up, especially when it's right there on the axis, because it's like right there at that number and you want to use it. But the domain for this is going to be 0 here, because the furthest, you're thinking furthest left, you got to think of x-axis. So go down and see what that x-axis is right there, and that would be 0. And then what's the furthest right point on this graph? Like, this keeps on going, right? So do we hit the graph like way over here? Like, we're still going right here, right? So what is my x-coordinate way, way, way over here? What? Say that again. Infinite, right? What kind of infinite? It is positive. It feels like it should be negative because you're going down, but unless you're doing range, you shouldn't be thinking about up or down. You're thinking about left and right. So that's going to be positive infinity. Your range. So now, Carson, we're thinking, highest point to lowest point. So we're still thinking about, well, here's our highest point. But this time, we want to look at the y-axis. So range is the only time you look at the y-axis. What's the y-coordinate at that highest point? That is 5. That's where we use our 5. Now, be careful with this, because like I want to go left to right, like my mind is wanting to go left to right. But 5 is the highest point. What have I got to start with? Lowest point, right? So the lowest point on this graph, what's the lowest point on this graph? Negative infinity, because it keeps on going forever, right? So range is going to be negative infinity up to 5. This graph is also not that bad to deal with because it doesn't switch from increasing to decreasing. It's just decreasing all the time, right? So you would have no increasing, and it's just decreasing all the time. And you're using x values, so your x value here where you start is 0, your y value way over here at the furthest left is infinity. It's the same as your domain here. And you'll find if it always increases or always decreases, that's going to be the same as your domain for that. Now, positive and negative is a little bit different here. So for positive and negative, positive is when we are above the x-axis. Negative is when we're below the x-axis. So above the x-axis is going to be here up to here. We don't want to actually include that spot where it hits the x-axis, so we'll use a parentheses for that part. So I'm going to show that with a open circle. So for positive, we got to give domain where this is positive. So we're thinking about x value. So Joey, right here at that first point that's above the x-axis, what's my x coordinate there? It's 0. Good. So we're going to say from 0 over 2, right here where I hit that x-axis and I start to go negative, what's my x coordinate there? It's not going to be negative infinity because once I go past this point right here, I'm below the x-axis. And when it's asking positive and negative, it's just like above or below the x-axis. So where do we stop here? 10. And I'm going to use a parentheses with that because it's neither positive or negative at 0. Right? Again, it won't be that big a deal on that. So then if I look at negative, right here, it's neither positive nor negative, but it is going to be negative the rest of the time, right, below the x-axis. So for negative, I'm going to have from 10 to, where does this stop? I may have seen someone mouth negative infinity. Is that correct? It's not, because negative infinity is y coordinates, right? That is going down. It's so hard to get your head to like wrap around this. What are my x? What's the x doing over here? Like what's my, so like my x coordinate here is 11, 12, 13, 14, 15. You got to think x coordinates. So my x coordinates go to positive infinity for that. Think about that x-axis. You're thinking about, oh, well, this is the part of the x-axis that we're looking at, right? So that is from 10 to positive infinity. Okay, so let's summarize here for a second, and I'm going to, then we're going to get into groups, and we're going to do like a one where we've got to do these all together. So I did not go over these because I think they are ones you should be able to find pretty easily. An x-intercept is a point where the function touches the x-axis. And a key here is that the y-coordinate is 0 at that point. So you're going to be doing these from graphs. You're just going to look for where they hit the x-axis. You're going to put the coordinates of that point, right? So it might be 7, 0. to 0. Functions can have several x-intercepts. There might be more than one. A y-intercept is a point where the function touches the y-axis, and the x-coordinate is 0. If you're looking at a function, there's only one of these. If it's not a function, it could have more than one, but if it's a function, there's only one of these. And again, you're just going to look at the graph, see where it crosses the y-axis, give the coordinates at that point. Okay? We also are going to talk just a little bit about absolute maximums and minimums and relative maximums and minimums. So your absolute maximum is going to be the absolute highest point on a graph. So when you're looking for that, you just look, what is the highest? Now, if you have a graph that has an arrow that goes up like this on the ends, is it going to have an absolute maximum? It will not have one. So this would be no absolute maximum because it keeps on going up forever. So you can't say infinity. Like, that's not a maximum. It doesn't really exist. You can't get there, right? Minimum is similar, but it's the lowest point. Some graphs have high, absolute maximums and minimums, but lots of them don't have either one. Relative maximum or minimums are not necessarily the highest point on the graph, but is a point where the function changes from increasing to decreasing. Okay, and so for this, it's going to look something like this. This point that I'm highlighting right here, is it the highest point on the graph? It is not, because you got this arrow that goes up, but it is higher than the points around it, right? So it is a relative maximum. A relative minimum is similar. That is going to be when you go from decreasing to increasing. There. And it, like if I had that same graph right there, this point right here, is it the lowest point on the whole graph? It is not, because you got this arrow that goes down over here. But this point is lower than the points around it. You have switched to decreasing to increasing. So like, you know, you might be the, let's go with relative maximum. You might be the absolute best player on Elkin High School's basketball team. Does that mean you are the best player in all of the world? Probably not. There's probably better out there. So you are a relative maximum, but you are not the absolute maximum for that, right? Questions? All right. Let's just do this one. How much more? Gosh, we're running out of time. We definitely can't do all these. What do I want to do? Let's do this one. Okay. X-intercept. What is my x-intercept on this? Where did I cross the x-axis? None. There's not one on this one. Okay? What about the y-intercept? Do I cross the y-axis? Oh yeah, I do. Right here, you're just going to give the coordinates of that point. So that is the point 0, -3. Okay? What about absolute maximum? What's the very, very highest point on this graph? Do I have one? I do not, because I've got an arrow that goes up forever right here, so you can't ever get to the highest point. So you would say none for your absolute maximum. What about my absolute minimum? Not one. Same thing. I got a down arrow, right? So that's a none. Okay? Relative maximum. I don't like this. In calculus, we would not do this one. Do I even want to mess with that? I think that, okay, let's see. No, I'm not in pre-calculus. In pre-calculus, we would consider this one right here a relative maximum. It's higher than the points around it, but you're not switching from increasing and decreasing. I think it's just pre-cal. I got to do that. I think we can say none for this. Like, we don't have a hump. Let's go with none. Because in calculus, it switches back to not counting. I don't know, it's confusing, but let's just go with none. You all right with that? All right, but relative minimum, no, we definitely can't do none for relative minimum. Do I have a low point on this graph? Something that's lower than the points around it? A dip. I've got one right here. There's my relative minimum, right? So I'm going to give the coordinates of that point, x coordinate, then y coordinate, so that would be -2, 1 for that. Okay, so tons of stuff you got to be able to know for this. Rather than go through the rest of these notes, because we've been